Yeah, exactly. Yeah, come race me in a 400. See how that works out. Yeah, I'm recording this, Maya. People live for these videos. Okay, who we missing today? Logan? Nobody cares. Marty, we miss you. Get back here, dude. We all love Logan. Everybody knows that. Tim's crying. Stop crying, Tim, because you miss Logan so much. All right, here we go. Shifted conics. You guys have to be able to look at this first one. It says 9x squared minus 72x minus 16y squared minus 32y equals 16. Here's the deal. It's either a parabola or an ellipse or a hyperbola. You don't know which. How you can figure it out? Put it in standard form. But do we aim for the form of a parabola, an ellipse, or a hyperbola? Which one do we aim for? So let's think about this. Do all three. Yeah, just do it all. X minus h quantity squared plus k. So remember, that's what a parabola looks like, right? Or it could have x equals a times y minus k quantity squared plus h. And in both situations, we say that the vertex is hk. Then we've got a shifted ellipse. An ellipse was x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. We did that last week, Tuesday. Some of you guys got your work done this weekend. Some of you did not. Center is HK. And then the hyperbola. How is the hyperbola different than the ellipse? Got a subtraction sign sitting in there. Remember that? So what you have to be able to do is you got to be able to look at these conic sections and be able to identify, well, what makes them different from each other? Like how is a parabola different from the other two? Okay, no division. Okay, doesn't equal 1. I got to figure out something that provides a difference so I can tell if number one's a parabola or not. Very good. Ishka's got it. So you got y and x squared, or you got x and y squared. You do not have both of them squared, do you? That's the dead giveaway. So is number one a parabola? No, because you have an x squared and a y squared. Are you clear? Would you agree that for the hyperbolas and the ellipses that you have x squared and y squared? So then how would you tell the difference between an ellipse and a hyperbola? Yeah, one of them's negative. So ellipse, both are going to be positive, but for a hyperbola, one of them is going to be negative. It's a hyperbola because one of them is negative. Let's group together our terms. 9x squared minus 72x minus 16y squared minus 32y equals 16. It's a very difficult lesson today. So much so that you need a full work day on the assignment for tomorrow. I'm going to complete the square. What do you factor out here? 9. What do you factor out the second part? Negative 16. Very good. You're so smart, Emma. You're welcome. What is it that I add to complete the square? 16. Parth, how'd you get it? Okay, x minus 4 quantity squared. You took the 8, divided by 2 to get 4, then you squared it to get 16. So now what do I do? Add 16 over there? Close, not quite right. Nope. Very good. 9 times 16. Have I taught you how to complete the square like this before? Yeah, I have. It doesn't mean that you remember it real well, but this should start to look familiar. What do you add to complete square here? 1. What's the actual value? Negative 16. So I have 9 times the quantity, x minus 4 squared, minus 16 times the quantity, y plus 1 squared, equals 144. Starting to look like a hyperbola, right? What do I have to do to make it look for sure like a hyperbola? Divide by what? 144. X minus 4 quantity squared over what? 16. Minus y plus 1 quantity squared over 9 equals 1. You gotta have fun somehow in class. You know what I mean? Like, exactly, we have fun. And we're gonna have fun next year. Emma, you're the best. Okay, so it's definitely a hyperbola. And so we're going to need center. We're going to need vertices. We're going to need, oh, that was really bad. We're going to need length of transverse axis, foci, and asymptotes. Who can tell me what the center is? No. 4, negative 1. All right, so now I'm going to make my graph. Make it a 10 by 10 here. Okay, so we've got this piece right here. I plot the center, 4, negative 1, okay? And there I am. Great. And now I'm going to show my vertices. How many units do I go in the x direction? I got to make my box. Got to make a ghost box. 4 units in the x direction. How about the y direction? 3. So we're going 1, 2, 3, 4. 1, 2, 3, 4. I'm glad we had that conversation. If you guys wouldn't have brought up the coffee situation, then we never would have, you know. I mean, that's how we got to that topic, and that ended up solving a problem for us that could potentially exist for next year. So 4 for x, 3 for y. Yeah, you got that? Okay, do the vertices go on the top and bottom or side to side? Why, Ishika? Yes, x is positive, so it's side to side. Y is vertical, so I go side to side. The x is positive, so I put the vertices on the sides of the box. So that has a location of, it looks like 0, -1. Stop it. And 8, -1. What did you just say, Emma? You don't think I'm what? Challenge accepted. Challenge accepted. Okay. Length of the transverse axis, distance between the two foci is, or between the vertices is 8. Good job. Yoon is ready to go. Foci. How do I determine the foci? A squared plus B squared. What's A squared plus B squared? 25. Square root 5. So I go 5 units from the center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I've got -1, -1, and 9, -1. 9? What 2 things do I have to determine for the asymptotes? Nope. Point and a slope. Very good. What's the point that both of the asymptotes go through? Very good, Noah. What's the center? 4, -1. Look at your box to determine the slope. Plus or minus 3/4. Which part? That could be fun too. All okay myself. So point slope form, y plus 1 is equal to plus or minus 3/4 times x minus 4. There, folks, is a hyperbola. That was a lot of work, wasn't it? We did the most difficult one first. The other 2 are a little bit easier. Need a hall pass? Okay, well, you let me know, and then I'll cancel out this guy. Okay, flip it over. Here we go. We're running out of time here. We're not careful. All right. What is this shape? Is it a parabola, a hyperbola, or an ellipse? Willie says parabola. Why? Because there's only one squared. They don't have both squared. They have one squared. So I've got x squared minus 4x. And then something equals 8y minus 28. Hey, the x's are already gathered together. Now what do I do? How? Plus 4. So now what? Add 4 to the other side. You guys are smart. X minus 2 quantity squared equals 8y minus 24. All right, you go. A lot of fun. All right, here we go. Now what do I do? How about we add 24? And then let's divide by 8. Very good. So 1/8 times x minus 2 quantity squared plus 3 is y. All right. We know it's a parabola. We identified that, so we're going vertex here. We're going direction. axis of symmetry. We're going to go focus, directrix, and length of the lattice rectum. All right, here we go. Yeah, sure, whatever. All right, so we're going to graph the sky out. I'm going to go 10 by 10. Okay, I think that's good enough. Okay, so I'm going to plot my vertex. What's the vertex? Two, three. I'm going to go over 2 and up 3. In the previous 2 classes, I have made a perfect parabola. I'm going to try for 3 in a row today. Thank you for your confidence. What's the direction? Up. Axis of symmetry. Say it like you mean it. X equals 2. How do I locate the focus point? No. Very good. A is 1 over 4p. Remember that? So we got 1/8 is equal to 1 over 4p. P is dos, Spanish for 2. Very good. So if P is 2, what does that mean? What do I do? How do I use that? Yep, 2 units from that. Very good. So I go up to this spot. So that looks like the focus is at 2, 5. And then the directrix, I go 2 units down. So y equals 1. And then I've got the length of the lattice rectum. Absolute value of 4p, which is 8. So I'm going to go 4 units to each side. Okay. What do you think? Is it perfect? Pick a spot there. Okay, thank you. Thank you. Round of applause, everybody. Thank you. Thank you. Thank you. I just want to let you guys know that this is the first time, like, I oriented the smartboard earlier, and you already do the button thing, and the first time I've done that in a long time. So I'm thinking that before when we were doing this, and I was trying for perfect parabolas, I'm going to blame the smartboard was out of alignment, and that now you can see I've got a perfect parabola. So I'm very proud of my parabola. Just gaze at the blue parabola for a second because it is perfect. So now you try to draw one. If you were a parabola, that's who you would be. Good for you. All right. That's how I would describe you too. So you're welcome. Yep. All right. Last shape. What do you got? It is an ellipse. Why? Both squared, both positive. 2x squared minus 12x plus y squared minus 6y plus 6y, excuse me, equals negative 26. Now what? So factor out a 2, and I get x squared minus 6x plus y squared plus 6y. Now what? Ooh, Willie's got it at 18. You see why? Add 9. 9! Two times 2 times x minus 3 squared plus y plus 3 squared equals 1. Can't be 1. How? But I'm not dividing by anything. Come on, you guys. Ellipses, you got to be dividing by something, right? That's the form. So it's y plus 3 quantity squared over 1. Like, I get that, right? Well, what about this one? It's multiplying by 2. Multiplying by 2 is the same as dividing by 1/2, right? Got to show what you're dividing by. Oh. There's a possibility. Oh, goodness. Okay. Yep, smartboard got stupid all of a sudden. Oh, it turned red, and now it's going to start blinking. All right, there we go. Center. After center, we have the vertices. We have the length of the major axis. We have the minor axis. We have the foci, and we have the asymptotes. Now, I want you guys to think about this one so you can start to see kind of how you make your graph. What is the center of this one? 3, -3. So which quadrant is that? Fourth quadrant. And you can see that the 1 is underneath y plus 3. So therefore, it's stretched more vertically, right? How many units is it going to be stretched in the vertical direction? 1 unit. So would you agree that this is not going to be outside of the fourth quadrant? If it's at 3, -3, it's just stretched 1 unit. It's going to be in the fourth quadrant, right? So therefore, as I make my graph, all I need to show is just this guy. 1, 2, 3, 4. 1, 2, 3, 4. So I plot 3, -3. And then how many units do I go in the y direction? 1 unit. How about the x direction? Maya's got square root of a half, which is 1 over the root of 2, which is the root of 2 over 2. Which, wasn't that also like the cosine of 45 degrees? Yeah, that's pretty cool too, huh? All right. So root of 2 over 2 is 0.7071. You guys know that. You took trig with me. That's impressive too, I think, right? Yeah. Yep. All right. So are the vertices on the top and bottom or side to side? Is it stretched more vertically or horizontally? Stretched more vertically, right? So the vertices are on the top and bottom. So vertices are 3, -2, and 3, -4. The length of the major axis is the distance between those vertices, which is 2. Length of the minor axis is the distance across it from the shorter way. So it's going to be double that, right? So what's 2 times root of 2 over 2 is just root of 2. Yep, lots of 2's in this problem. And then foci. How do I find foci? Close, that's eccentricity. Well, I wrote a symptom. I did that the other hour too. The eccentricity is what we want. Yeah, thank you for speaking up. All right. Speak up next time. Foci. I have to find what value? C. How do you find C? A squared minus B squared. So A squared minus B squared. 1/2. Then you got to take square root, and you get C is root of 2 over 2. Or 0.7071. So from my center, I'm going to go 0.7071 in each direction. So the foci are located at an x value of 3, and then the y value, I have -3, and I add and subtract the root of 2 over 2. So finally, the eccentricity, Ishika, what's the formula for eccentricity? C over A. What's your C value? Root of 2 over 2. What's the A value? 1. What's the root of 2 over 2 divided by 1? Root of 2 over 2, or the cosine of 45 degrees. A is the square root of the bigger value, so A is the square root of 1. So, yeah. So it's, 0.7071, which is kind of cool. So. All right. The assignment is complicated enough. You need a full work day tomorrow to work on it.